Good morning, kids, or afternoon, depending on when you're watching this video. Today, I want to go over, I'm going to do some things a little bit different. This video is basically just kind of say hello to you. Um, I know we're not doing the conference thing, so I thought I'd start trying to make some of these videos for you. But anyways, you'll see on Schoology today that our agenda is obviously we don't have any homework because everything's homework right now. And you'll see that we have the agenda posted. And the first thing is number one, complete any missing work that you might have that you didn't get done in previous days. But everybody's doing a really nice job with this long distance learning. Number two, if needed, please watch the number 11A topic 12.4 helper videos. Those are posted in materials, and you can watch those because they'll go over some of the basics that were in yesterday's video, but they're only like 1 or 2 minutes long if you need a refresher. If you don't need to watch those videos, then you can go on to number 3, which is please complete the number 11 topic 12.4 area of special quadrilaterals assignment. It's just your typical assignment. Open up the quiz and materials, multiple choice, get them done. And then number 4 is if you would like to do some enrichment, go ahead and sign into ST Math. Okay, so that's the agenda for today. And I did have a chance to review some of the assignments that were turned in yesterday related to finding the area of special quadrilaterals. And I'd like to bring up a couple things, okay? I'd like to go over a real quick review here, okay? And when we're talking about finding the area of special polygons, what your assignment is today, keep in mind a couple things, okay? Keep in mind that, number one, you need to decide if it's better to compose shapes from the original shape or decompose shapes from the original shape in order to find the area. So in other words, you might need to break a shape down or recombine it into another shape to find its area. All right? The second thing that I'd like you to keep in mind is that you need to check for missing assignments, or missing measurements, and build those in accurately to any composed or decomposed shape you make. So in other words, you need to, if you decompose a shape, the original measurements will probably be accurate and they will work, but if you decompose a shape and turn it into something else, then you have to look at the measurements and make sure you transfer them accurately. Sometimes you have to double them, sometimes you have to cut them in half, sometimes you add, subtract. But be careful when you compose or decompose shapes that you remember the original measurements. And then the third thing is to use the formulas if you know them. So the third thing is use your formulas correctly if you know them for the polygon you're working on. So if you know the formula for finding the area of a trapezoid, by all means, don't bother decomposing or composing it. Just go right ahead and figure out the area, okay? So anyways, a little refresher here on what it means to compose or decompose a shape. All right, I'm going to move myself off to the side here. Okay, decomposing versus composing. Here's a kite. That's what we like to call that shape. Okay, and if you were to take that kite and decompose it, what you would do is you would break it into smaller, more easy to work with shapes, okay? So in other words, this shape, this kite, has been decomposed into a couple other shapes. Been decomposed into 2 smaller triangles and 2 larger triangles, okay? So it's been decomposed into 4 individual triangles. And then what you could do is find the area of each one of those triangles, okay? So we're going to put that back together. And then we can talk about composing things. Now, if you can decompose something, you can recompose it into something more useful or easier to work with, okay? So now we're going to look at the same kite and how we could take it and turn it from a kite into a rectangle, okay? So I'm just going to take this triangle right here, and we're going to flip it and transfer it to the other side, okay? So now you can see where I took it from here, I flipped that upside down, and I place it over here on top of that. Now we have a rectangle. Okay, you can see where we're going with this. So now I'm going to take this triangle and I'm going to flip it. And then I'm going to park it right up against the other longer triangle. And now what we've done is we've created a rectangle from our kite figure. And this rectangle is kind of nice because now we can easily figure out the area of that rectangle. This rectangle is the same area as the original kite. We just recomposed it using the larger triangle and the smaller triangle and putting them on the other side. Okay? Here's an example of decomposing and composing on trapezoid. Okay? In this case, you can take the trapezoid and you can break it down into a rectangle and then two triangles. And so if you wanted to, you could figure out the area of each triangle, add them together, and then find the area of the rectangle. Or you could use this process of decomposing to recompose things into like a rectangle. So if I take this and I flip it, I can then park it up above the other smaller triangle, and then what I have is I have a working rectangle that has the same area as the original trapezoid. Whoop. Okay, so if I get rid of that, I can see that there we go. All right, so it has the same area as the original trapezoid. We just parked the shapes in different positions. Okay. Now, yesterday you were asked to do a quick check, and one of the problems on the quick check was to find the area of this trapezoid. Okay, well, trapezoids are kind of neat. Okay, they're made up of one set of parallel line segments, and they usually, what they have is they have a base 1 and a base 2, which means that the area can be found by taking half of base 1 plus base 2 and then multiplying it by the height. And so this is the formula for finding the area of a trapezoid. And so if you understand this formula, you don't even have to compose or decompose any part of the trapezoid. Okay, so the area of this trapezoid is actually 24 square inches. Okay, and so you might decide, well, I'd like to compose it into a rectangle or decompose it into separate shapes, okay? Because certainly you could do that. In other words, you could say, all right, I'm going to take the rectangle that is in the center here, and I know that that is 6 times 3, which is 18, okay? And then you could easily say, okay, well, now I have two triangles that are congruent. Each one of them is a base of 2 and a height of 3. And then you could simply apply the formula for finding the area there, which would be base times height, which is, in this case, 6. And then divide by 2. Or, if you like, half the base times width, all right? But now we do 6 divided by 2 equals 3. So each one of these little triangles is 3. So if you have 3 and you have 3, you have 6. 6 plus 18 is 24. Okay? Now I'm going to show you kind of how to use the formula for finding the area of a trapezoid. Okay, so I'm going to kind of get stuff moved out of the way here for us. Okay. All right, we'll just slide that all up in there. Now, if you look at the formula, it's 1/2 of base 1 plus base 2 times the height. Now remember, order of operations means that we have to do what's in parentheses first. So if we take base 1, which is 6, and we add it to base 2, which is all the way from there to there, is 10, okay? We can add those up and we get 16. Well, now we have to do 1/2 times 16, 1/2 of 16 equals 8, okay? So now we have everything done from here and inside the parentheses, so now we multiply that answer, 8, times the height. Well, the height is 3. So if we take 8 and we multiply it by 3, we get the answer that is 24 square inches. Okay? So that's how we would solve finding the area of a trapezoid using the formula. Okay? Now, on to the kite. Okay? Now, take a look at this polygon. This was another question out of yesterday's quick check. And when you look at the kite, you can see that it's got a lot going on here, okay? You can see that the distance from here to there is 8 meters. The distance from here to there is 30 meters. And then from this line of symmetry, it's 12 this way and 12 that way. That tells us that we have two congruent triangles here, and we have two congruent triangles here, okay? They share the same measurements. So the answer to this, the area, is actually 456 square meters, okay? And you could either choose to compose it or decompose it to find what its area is. A lot of kids like to attack this by saying, okay, I'm going to find the area of one triangle. Well, this one triangle would have a height of 8, so this would be a height of 8, and then it would have a base of 12, okay? So if you multiply 8 times 12, I'm going to bring up my calculator because it's perfectly acceptable to say, oh, okay, 8 times 12 equals, 8 times 12 equals 96, okay? So we know that this one little triangle right there, okay, is 96 square centimeters if you multiply base by height. But remember, now we have to divide it by 2, okay? So if we take that 96 and we divide by 2, we get 48, okay? So one of these little triangles, okay, one of these little triangles right here is 48. Now, the interesting thing here is there's two of them. Well, of course, 2 times 48 gives us our original 96. So this up here, this section of the kite right here, is actually going to be 96 square meters. Okay, so now you can figure out the area of one of these triangles down here. Well, if I look at one of those triangles, okay, I can see that it has a, now remember, base and height can be, you know, relative to the way it's positioned. So I know that the base is going to be this, and this will be its height, okay? So its base is 12, and its height from here to there is 30, okay? Whoops, not a very good 3, is 30. So when we do the multiplication and we do 12 times 30, we get 360. Now, we do know that we have to divide that by 2, which is 180. So each one of those triangles is 180 square meters. Now, if this is 180 square meters, the other side has to be 180 square meters, okay? Or 360, okay? Because we would combine them. So now we know that the area of these two triangles, 360 meters, the area of these two triangles is 96. All we have to do is add those. So we can take our 360 and add it to 96, and we get our answer of 456 square meters, okay? And there's another easier way of doing this, okay? So I'm going to show you another easier way of doing this. I'm going to get rid of all this for you, okay? And that was decomposing it to come up with the area. And there's a lot of different ways you can decompose and flip and switch things. But what you'll discover this is pretty easy with kites. If you take this triangle right here, okay, and you take it and you get rid of it and you put it over here, you flip it and rotate it, okay, watch what we begin to do. Okay, we're going to flip it, park it in there, okay, so now we've gotten rid of this over here. Okay, that's gone. Okay, it's no more. It's been flipped and moved over there. So now we're going to take this triangle, okay, and we're going to flip it to the other side. So I'm going to try and draw it very carefully. Bring it on up like so, okay, and I'm going to bring it over here, and then I'm going to flip it up and down, and I'm going to park it in there. Now, it's not the best drawing in the world, but what you can see now is that we actually have a rectangle formed up from our kite. Okay, so we actually have a rectangle now, okay, that it is basically a length of 38, okay, so now we can use the area for finding the formula for finding the area of a rectangle by doing length times width. Okay, so we can do 38 times the width. Now the width in this case is this 12, okay, because if you look at it, it's right there. It's 12. So 38 times 12. And when we do that, we don't have to do any division or anything fancy. We just simply do 38 times 12. And we get 456. Okay? So anyways, hopefully that cleared up some confusion you had about yesterday's shapes. Remember that when you're finding the area of special shapes like trapezoids and parallelograms, hexagons, octagons, there's a lot of different ways you can compose and decompose things, okay? But just keep track of your measurements, and remember to plug in the formulas if you know them and you can use them accurately. All right, hopefully this little review did you some good. Wanted to just make sure that I got a chance to say hello to all of you. I hope you are doing well. And hopefully I'll continue to post videos like this from day to day. But let's go back and call it a day with this little video. Okay? And remember, today's agenda is to, number one, make sure you have all your work done. Number two, watch the helper videos. If what I just showed you wasn't good enough, go back and watch the helper videos. And then complete the number 11 topic 12.4 area special quadrilateral assignment, and then any enrichment you want to do, you can do on ST Math. All right, kids, we'll see you. Have a good day.